Hello, welcome for our today's science lesson. We are still moving on with the global issues, and in the previous lesson we looked at various causes of climate change. Just to make a recap shortly, we learned that the climate change occurs because of some various factors, including the reflectivity of energy and solar radiation into the Earth's atmosphere. Having looked at that, we also found out that both of these climate changes, they occur both by natural and human causes. In the previous lesson, we looked at various natural causes. We looked at various natural causes of climate change, and here we learned various aspects of these natural causes of climate. One, we looked at the characteristics, the changes of the Earth's orbital characteristics as one, changes of the Earth orbital characteristics. The Earth orbital characteristic was one of the items that we discussed under the natural cause. We were also able to look at various changes in the atmospheric carbon output. That is variation in carbon, that is carbon 4 oxide output into the atmosphere as a factor that also gives us the effect or the consequences as a factor that gives us the natural causes of climate. The third aspect, we were able to look at the volcanic eruption. At volcanic eruption, emitting some of the smoke, dusts, and gases into the atmosphere. It could also lead to the blockage of the solar radiation, and thus interfering with the solar insolation from reaching the Earth's surface. After we were able to look at that, the further aspect, we also looked at the variation in the amount of solar output. The variations in the amount of solar output into the atmosphere. And these changes could be triggered by various solar insolation, as we were able to look at the rates at which the energy is absorbed into the atmosphere, while others are being reflected back into the space, thus interfering also with the solar insolation on Earth's surface. That one causes a drop of temperature on Earth, and therefore in some given areas the Earth's surfaces will give more of the heat or the temperature, thus increasing the temperature in form of the infrared radiations that have been experienced on the Earth's surface. Now, when we look at these various aspects, deeply we were able to look at the changes in the Earth's orbital characteristics. That is where we mentioned the changes in the period of aphelion and perihelion. You'll find that the Earth's orbital characteristic also changes, almost be circular, when the Earth is actually almost near circular during the aphelion period, and during the perihelion period, when the Earth is nearest to the Sun, that could also make the orbital characteristic to change and therefore influence the major part of the climate, especially in temperature. When we were able to look at the variation in carbon dioxide output in the atmosphere, when there was a natural rise in temperature that causes the carbon dioxide that is especially held by the waters, mostly in the ocean, the seas, when the temperature increases, you'll find that most of this carbon dioxide is released. And once it is released into the atmosphere, you will find that it adds up to what we call the carbon dioxide output into the atmosphere, which leads to the global temperature rise. At the same time, we also have some flora and fauna. Some of the plants uses carbon dioxide maximally, especially during the day, and during the night some of the plants releases plenty of oxygen, and which is also used by animals. An argument was, suppose we do away with all plants, and therefore we will have a problem. That means the rate of carbon dioxide will increase because the plants helps to balance the carbon cycle balance into the atmosphere, and thus creating an impact on the atmospheric temperature, which affects the average climate patterns. And as a result of that, most of these variation in the carbon dioxide output is also an advantage because it adds up one of the greenhouse gases, which also accumulate in the atmosphere and behave otherwise the way it is expected. And a number of these greenhouse gases we had mentioned in the previous lesson, such as methane, nitrous oxide, carbon dioxide itself, and also sulfur dioxide. Having been able to look at this, we also have to move ahead and look for the natural causes. That is, after natural causes, we have to go and look at the human causes of the climate change. And then shortly we will be looking at the consequences of this climate change. What are these human causes of climate change? From pre-industrial period, we learned that because of the industrial revolution, we have been able to find out that there are various human activities that plays a vital role in altering the climate aspect. especially when human beings continue burning fossil fuels. The burning of fossil fuel plays a major role in the climate change. Why? Since we have an energy demand in most of our country because we are in industrial era, that is since 1700, we learned that after industrial revolution, many countries, many states require a lot of energy. And that energy is obtained from burning of the fossil fuel. Most of the industry, especially when we look at the transportation system, they use coal, which has been able to contribute. For example, the burning of coal. Burning of coal contribute about 65% of the carbon dioxide which is released into the atmosphere. And this gives off the main gas of greenhouse gas that is going to accumulate into the atmosphere, such as carbon dioxide. Not only burning of the fossil fuel, when we look at most of the industries, I've just used an example of industry that require coal to produce, to have power so that to run the industrial activity. We also have some other fuels such as oil, that is the petroleum products that are obtained from oil. When they are also burned, they release a relatively good amount of carbon dioxide which accumulates in the atmosphere. When these gases accumulate in the atmosphere, including other greenhouse gases, they accumulate in the upper layer, in the lower layer of the atmosphere. And thus, when they do that, you'll find that the temperature will tend to increase, therefore altering the average temperature of that region. And it becomes a global issue of which contributes to the aspect of the climate change. That one is not enough. Human activities are full. For example, there is also burning of vegetation. There is also burning of vegetation. Some human activities such as clearing of the bush for the purpose of settlement or even for the purpose of expansion for industrial activities, you will find that during the shifting cultivation, the forest fire were very much known, and this added up a relatively good amount of carbon dioxide in the atmosphere, leading to the average rise of the temperature into the atmosphere. This could create a resultant consequence of global warming, because when there is too much greenhouse gases accumulated into the atmosphere, they form a layer of canopy. And this canopy, when these gases are now released into the atmosphere, they just come and hit this particular canopy, and then they also they are reflected back, therefore making an average rise of the temperature in the stratospheric zone. And therefore, when also during maybe some rain season, you'll discover that because of the accumulation of these gases around this zone, you'll find that when there is rain, the rain will dissolve a good amount of carbon dioxide. When it is dissolved, it is within this zone of the stratospheric or the stratosphere, you will find that another component of ozone layer is being destroyed. As a result of that, there are consequences will be felt on Earth. That is what we will be looking there after this. That is not enough when there is burning of vegetation. There is also clearing of large tract of land. Clearing of large tracts of land. When these large tracts of land, when the large tracts of land are cleared, especially that of forests for agricultural purposes and maybe settlement of human being, or you want to establish an industry in particular area, you go and clear out the bush or clear out large or an expansive part of land that had been occupied by vegetation, such as forests. You will realize that when you clear out this vegetation or forests, you are reducing the main disposal agent in the system, especially for the carbon dioxide from the atmosphere. When you reduce the main disposal agent, the main disposal system, the main disposal agent in the system of the Earth, you are altering and interfering with the amount of carbon dioxide increase, and also that could add a relative amount of carbon dioxide into the atmosphere. And therefore, it may alter the climate change. Having looked at these three aspects of human causes, we can still continue. We can still continue to look at other aspects such as industrial development. Many industries or many countries are putting up varieties of industries, and most of these industries, they depend on fossil fuel for their energy production. And as a result of that, most of these industries, they release various gases. The industries release various gases. They releases gases, and these are the greenhouse gases that are experienced, that are added into the atmosphere, such as methane. We have nitrous oxide, and then we also have other gases such as chlorofluorocarbon. That is the chlorofluorocarbon becomes another industrial gas that is released. That one carries what we call chlorine element. We also have that is carbon dioxide is also another gas. When all these gases are emitted in the atmosphere, when you visit the industrial zones, you will discover that on every town or every city, there are some industries emitting smoke. This is just smoke. And when you look at this smoke from the industry, this is the chimney. when you look at this industry, there is a release of various gases into the atmosphere. What do these gases play? These gases are called the greenhouse gases. Majorly when they are released into the atmosphere, they are going to cause what we call disastrous consequences, especially into the atmosphere. For example, when carbon dioxide has increased in the atmosphere, we learned that it leads to acid rain. What about the chlorofluorocarbon? Is also an element that we can easily obtain it from aerosols, which also may lead to the chlorofluorocarbons lead to also that is either global warming and also acid rain. Let us also look at the nitrous acid. This is an acidic gas. All of them may at least result into disastrous consequences, whereby you will find that the ozone layer is going to be destroyed. And it becomes a consequence, we shall look at later, how the ozone layer is proceeding to destroy. When we look at this, most of these industrial gases, because of the demand of the energy which is obtained from the burning of the fossil fuel, the waste products such as methane, nitrous oxide, chlorofluorocarbon, we also have the carbon dioxide, they damage ozone layer. And ozone layer is very important. It filters the greater percentage of the ultraviolet radiation which is given off by the sun. Having done that, this will cause an average temperature rise on Earth. When the average temperature rise actually increases on Earth, we will learn that one is going to lead into the climate change. Actually, the Earth's temperature depends on the balance between the energy that is entering into the atmosphere. It is good to make out this point. The Earth's temperature depends on the balance. The Earth's temperature. The Earth's temperature depends on the balance. The Earth's temperature depends on the balance between the energy that is entering the Earth, the balance between the energy that is entering the Earth and that energy that is leaving. There are two aspects that we have to be able to understand here. The Earth's temperature depends on the balance between the energy that is entering the Earth and the energy that is leaving the planet system. When the incoming energy from the sun is absorbed by the Earth systems, the temperature will rise up, leading to the warming up of the atmosphere or of the Earth's surface. And most of the factors are actually coming from both the natural and the human, which causes this energy to balance. And some of these factors actually that makes the energy to balance, for example, one is the variation in the sun's energy. Variations in the sun's energy, that is in the solar energy. When the energy varies to reach the Earth's surface, then there will be a problem. Solar energy that is reaching the Earth's surface. That one becomes a very important factor when there is variation in the sun's energy reaching the Earth's surface, and therefore there will be consequential altering of the temperature. Another aspect is the change in the reflection of the Earth's atmospheric surface. That is the change in the reflection. The reflection of the Earth's atmospheric surface when there is a reflection on the Earth's atmosphere and also the surface, it's actually the atmosphere and the surface. The atmosphere and the Earth's surface, it also leads either lowering of the temperature or rising of the temperature in some particular regions of the Earth, leading to what we call temperature rise that makes the climate to change. Also, when there is a change in the greenhouse effect amount, changes in the greenhouse gases amount, when there is a change in the greenhouse gas amount, it affects the amount of heat which is retained. This one normally affects the amount of heat that is retained by the atmosphere. When there are these changes, then there will be a relative change also on the temperature, leading to what we call global climate change. As we move ahead, when we move ahead prior to the Industrial Revolution, that is majorly in 1600, the climate change could be explained by either natural causes, most such as volcanic eruption, solar energy, and the solar variation output, and the natural changes in the greenhouse gas concentration. Let us look at this part that is analyzing the atmospheric carbon 4 oxide since 1960 to late that is the year 2010. When we look at it, it will be quite very important. As we look this graph, it is going to help us to analyze some of the changes that are occurring. This is the atmospheric carbon dioxide. Analysis. There are some rates, that is parts per million. We can have 300 parts, 360 parts. Then we come to 400 parts, 440 parts, 480 parts of the atmospheric. That one is measured in millions. That is in the year 1996. And then we move to that is 1960, I mean. Should be 1960, then 1970, 1980s, 1990s, and then we have 2000s, and then 2010. We have the 1960, 1970, 1980, 1990s, and then the year 2000, and then the year 2010. That is 2010. The amount of carbon dioxide that is analyzed since that period of time, we'll find that there is an increase beginning from 0. In 1960 it was very low. In 1970 it increased because of industrial activities. 1990 it has increased. 2000 and 2010, the rate is actually increasing. When we take the curve, when we look at this graph, the atmospheric concentration has really been moving up. There is an increase that is rising from the industrial levels. That is by 480 parts per million. That is over 400 parts per million that has been used in the year 2010. This is the amount of million parts that have been used in the year 2010, and the rate is still increasing. What do we have here? What we are concluding that there is a high rise in the amount of, that is carbon 4 oxide, carbon 4 oxide, where that one is in the atmosphere. And as a result of this, the rate at which this is rising, discover that in early 1960s, the rate was very low. But now in 1970s, the rate has increased. In around 1980, 1990s, look at the rise. By the year 2000, it is increasing. By the year 2000 also, and 10, and this is 2017, what do we expect? The rate of the carbon 4 oxide output, the rates compared before the industrial period, it was very low. But now, after the industrial revolution, the rate now in early 2000, that is from 2000, look at the rate. It is increasing exorbitantly. Every year there is an increase. What about the few coming years? Because we keep on looking at this and we do not do anything about it, this is going to cause an automatic climate change in various parts of the world. And it is becoming a global issue that we have to take part and look into it as we try our level best to improve. It is very, very quite important. Also, it is very important as we look at this chart, it will help us to analyze various aspects. This is as a result of the human-induced, the human causes. Therefore, human beings are also playing part. We have been able to mention that is most of the human activities, such as the burning of the fossil fuel, burning of fossil fuel is resulting into this, clearing large tracts of land, that is clearing the bush. Let me say bush clearing. We are also, human beings are involved in industry, that is in industry expansion. That is, they are expanding industries, and as a result of that, there is a more energy that is needed for these industries to survive. As a result of that, there is a lot of emission of the carbon 4 oxide gas in the atmosphere. And if this rate keeps on rising and increasing, what is going to happen? What will happen is now the consequences. We will have various consequences that are going to affect various parts of the world in terms of the global issues in the climate change. Now let us look at the consequences of climate change. After looking at the analysis of the carbon 4 oxide output into the atmosphere, we are almost developing an alarming rate. We'll be able to look at the other various analyses maybe later, but at the rate at which the carbon 4 oxide is increasing, is added into the atmosphere, is actually fierce. What are its consequences? There is a great consequence on this. One, there will be an increased amount of rainfall. there will be an increased amount of rainfall in various regions. If we are going to have an increased amount of rainfall in some parts of the world, it is going as a result of high temperature. The amount of rainfall is increasing as a result of high temperature. When this amount of rainfall increases as a result of high temperature, it will cause high rates of evaporation. Also, high temperature leads to high rates of evaporation, causing some areas, especially the wet areas, to become more wetter and flooded. We will also be able to experience what we call flash floods. That is as a result of that. While in the dry areas, we'll be having some regions becoming dry and more drier. As a result of that, you will find that when a region becomes too dry, there will be a problem also with food, both for flora and fauna. Then that means that we will not be very much comfortable living on the planet, that is on our environment, because we are realizing that most of these consequences are still coming back on Earth, where human beings are living, both human beings and animals. Then we will not be able to have the best environment for us to survive. Another consequence that will happen is the global warming. That is a topic for the next. But global warming comes as a result of the increased effect of the greenhouse effects, which is added into the atmosphere. Hence, there will be a lot of destruction. Destroying of the ozone layer. When the ozone layer is destroyed, the consequences are coming back on Earth. We will have what we call the skin cancer. We'll also be able to experience eye problems on Earth and other various perennial diseases which affects human life on Earth. And then also there will be effect on agriculture. We will experience effect on agriculture. There will be an effect on agriculture. Why? Because as a result of the regions where crops have been growing, these regions could shift in cooler regions or in cooler altitude and latitude regions. For example, the wheat which is been growing in the areas of Canada, it could possibly shift in the North Poles, causing failure in crop production in Canada itself and other areas where other regions or some parts of the world that have been depending on Canadian production of wheat, where the temperature have increased, that will be the resultant cause. Again, we'll be able to experience some other consequences. That is the fourth consequence. We will have shortage of water. We will be able to experience shortages of water. And perhaps it is quite important to note that water is a resource and it is always on high demand. If we are going to experience shortages of water, when the climate becomes dry and drier, causing very little water to infiltrate into the ground, leading to less water that is supposed to feed some of the underground rivers and lakes and perhaps the ocean, because there is high temperatures that is causing what you call evaporation, high rates of evaporation. High rates of evaporation is also going to bring about this effect. Then some of our industrial activity that depends on water resources to run, there will be a problem. And perhaps human life will be very much hard without water. How will you survive without water? That is my question for us to brainstorm. How will you survive without water? How are you going to survive without water if we will have water shortages? That becomes a consequence. Let's move to the next consequence as a result of the climate change. We'll be able to experience abnormal growth of plants. How will you survive without water as a result of the climate change? We are looking at another consequence, such as an abnormal growth of plants. We will have an abnormal growth of plants as a result to increased amount of carbon dioxide, which is an output causing high rates of photosynthesis. These rates of photosynthesis, when they increase, we'll find that we'll have an increased production of some other unwanted varieties of maybe crops that will be resultant, especially now, like we know of a given crops that it takes around maybe, let's say potatoes takes around 3 months to 4, between 4, there will be an abnormal growth. These rates of growth will be reduced maybe to 2 or even between 1 and 2 months. That means there will be an accumulation of problems in this food. Another consequence is increased ultraviolet radiation. We'll have an increase in ultraviolet radiation. The consequence of an increased ultraviolet radiation is that it is going to cause human diseases. Why? There will be a problem on the skin of a human being that is causing what we call the skin cancer, and we may also be able to experience eye problems as a result of the increased rate of ultraviolet radiation. This will also consequently lower the crop productivity by slowing the rate of photosynthesis and germination. When we have excess ultraviolet radiation, we will always have a higher rate, a slow rate of photosynthesis, and also germination will be reduced. Lastly, we will have excess heat. We will have heat and waves, excess heat and waves in the ocean. When we will experience excess heat and waves in the ocean, this is as a result of the increased temperature. When there are large waves in the ocean, actually it sometimes interferes with the coastal or the marine life, leading to fatal deaths and destruction of properties. Because high waves always destroy some of the properties. Properties are always destroyed as a result of the high waves. Some of the waves may be generated into the ocean as a result of volcanic eruption. You remember a wave such as the tsunami? The tsunamis may also occur and they destroy some of the human property along the coastal regions and lead into what we call fatal death. These and other things becomes more consequential on the climate change. We have been able to look at the various parts of the climate change. Let us finally look at the chart. Now, when we look at this chart, we have our first part, that is the first illustration. This is actually a sketch map of Australia. This sketch map has got some predicted future changes in Australian cities. There are various cities that are in Australia. I will request you to use the map to identify various cities. For example, the city that is found here. You also discover this city and find out about this city that I have circled, so that we are going to analyze together what is happening in these cities. I have labeled them with different letters, that is A, B, C, and D. Throughout, these are the temperature changes by the year 2030. The temperatures are going to change by the year 2030 as a result of the increased rate of carbon dioxide production, which is added into the atmosphere. Now, I have brought some of these letters on the scale. This is an average scale of 0, 1, 2, 3, 4, and 5. This one runs up to 7, 1, 2, 3, 4, 5, and then we have 6. This is 7. This is actually an average temperature. An average temperature change in degrees. That is, temperature is changing in degrees Celsius. Both applies on this part and this part. But this is for the first area that accounts for the year from right now to the year 2030. We'll have the rate of the regions that are marked A. Their rate of change of carbon dioxide output will be around 1.5 degrees Celsius. That is the regions that are marked B on this chart. For example, these are the region marked B. We look at this region marked B. B, 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 B. We have B, these towns. We have the regions that are marked C. We have D. And we have A. These regions, I've represented them here. But now, graphically, we'll find that the regions that are marked B will have an increased temperature of around 1.8 degrees Celsius. The regions that are marked D will have recorded around 2.4, that is 2.4 degrees Celsius. That means there is an increase of temperature. By the year 2030, this will be the result of the temperature change. Now, when we also move to the year 2070, I've just added 40 years, what will be the change? We will have a sudden change of the regions that have marked D. When we compare with these regions, it has increased up to a maximum of 7 degrees Celsius. That is an average every year. When we come to the regions that are marked C, there is having an increase. This is 6, an average of 6 degrees Celsius. That is an average temperature change. B, the regions that are marked B, are running from 1.5 to 5 degrees Celsius. And as a result of that, what does it mean? Let's also compare the regions that are marked A. They are having, this is 1.4 degrees Celsius. In the year 2070, maybe if the rate continues, it will be around 4.3 degrees Celsius. Then, if we just mark this area as 4.3 degrees, this is 5 degrees, this is 6 degrees Celsius, and this is 7 degrees Celsius. What do we learn? There are going to be fatal consequences on the global climate change. And this is what is striking the Earth's surface. I will give you just one of the questions concerning these parts so that we are going to outline them. Propose the reasons why the areas marked A on the map are predicted to have only a relative small temperature. Why the regions that are marked A have relatively small temperature? This is my question. Propose or give a reason why the regions marked A have relatively small temperature rise, small temperature rise, that is by the year 2030. As you looked into it, I will give you the second question so that it's going to help you to outline this concept. Outline some possible effects. Outline some possible effects. Some possible effect on the environment. The possible effect on the environment. One, on the people. When you look at the people and the weather, of the surrounding regions or surrounding areas, that will occur in the regions of the areas of Canberra. I will outline the regions of Canberra. As a result of the predicted temperature rise, these areas that are marked A, B, C, D, they represent some of the towns in Australia. Use your atlas map to locate and identify most of these towns. That is the part. Identify this town, identify these towns that are marked here. And then it is also good you identify the towns marked A. After identifying them, there are some predicted future temperature changes by the year 2030. You look at them and note them down, and also note at the year 2070. Having done all of that, we'll be very happy to have done the consequences of climate change and its analysis even to the coming future generation. With those very few remarks, thank you for your attention. We'll move on in the next lesson. Good day.